Happy Thursday. We're going to continue in force and motion today, continue to really identify the correlation between force, mass, and velocity. Look at 2 simulations today, do some analysis, and we're almost done with the week. The do now is asking you to identify when there's 2 cars or objects, they have the same mass. They have different final speeds though. Which car do you think experiences the greatest force at change speed? The first car experiences the strongest force because it has a higher velocity. The second car experiences the greatest force because it has the greatest change in speed. And the first and second car experience the same force because they both have the same mass. And when an object slows down, it takes more energy for an object to speed up. So write your response here, write what you think, and this is going to guide us into our lesson for today. Same key vocabulary, so I'm not going to go over that. This is the same as yesterday. A super similar simulation, but we're going to look today at friction. So specifically that force that goes against an object that causes it to slow down. Again, the instructions are here at the top. If you need any help, hopefully that can be used as a resource to help you, and I'll continue to walk you through it. The table today, we're looking at the same objects: a small human, the wood box, tall human, refrigerator, and a mystery object. So we need to record the masses. There's going to be a force applied with the object, and then the friction of force going against it. We're going to calculate the sum of forces and the time it gets an object to move at 20 meters per second. So the first thing I want to do is, obviously, I want to go into the simulation. And I'm going to click on the friction option. Like always, I want to make sure that all of my values are selected. And I'm going to go back and look at my table. So the first test I have is a small human. And I'm going to apply 50 newtons of force to the right and 25 newtons of force friction to the left. So let me set that up. I'm going to pull a small human up here. I like to hit pause first so they don't move. I'm going to apply friction to the left. I forget how much I need. Let's see. 50 to the right, 25 to the left. So I can see that once I apply the force, I can see how much friction is applied. And I need 25, so I need to reduce this a little bit. Now all the numbers are right here that I need to have. I have the force of friction, the applied force, and the sum of force. So in my table, I want to make sure that those are all recorded. I'm going to hit play, and I need to record the time it gets takes the object to move about 20 meters per second. So I'm going to hit play, and I'm going to go ahead and record that. Pause. Okay. Now, I recorded that it took about 13 seconds. I'm going to do the same thing, and I'm going to use the small human again. So they're 40 kilograms. Now, I'm going to apply a much stronger force to the right. 150 newtons of force, and I'm also going to increase the amount of friction. So I'm going to go back, make sure my values are all on, put the human back on, and again, I'm going to hit pause. I like to hit pause first. 150 newtons of force to the right and 50 newtons of force to the left. I'm going to get my timer ready on my cell phone, and again, I'm going to record how long it takes the object to get to 20 meters per second. So let's time it. And pause. Took 7 seconds. I'm rounding. You don't need to be perfect, but you want to be able to identify a trend. So it took me 7 seconds. And again, that makes about sense. It took almost twice as long for when we added more force, so it took less time. Now the sum of forces is 100 newtons to the right. I'm going to go ahead and complete that. I did the first one for you for the refrigerator. The refrigerator took a little bit more time, so hopefully this will speed you up a little bit through this process. And make sure that you analyze and come up with the key ideas. The key ideas for us are we need to associate force, mass, and acceleration. So when there's an opposite force, what direction does that go? And then depending on the environment, I want to hear a little bit more about how having more or less force, sum of forces, impacts the speed of an object. So go ahead and write your responses here for 1 through 4. When you're ready, move on to part 2. The second simulation is an amplify simulation. I want to review a little bit before we get started on collisions. Again, instructions, table, analysis. So make sure that we complete all the parts required. I'm going to go ahead and open up the simulation. And I'm instructed to go to 3.2 same mass collisions. Top left, make sure I go down to 3.2 same mass collisions. Now in my table, I have 2 different objects, object A and object B. I need to record the effect after the collision and the force of strength after the collision. There's a starting velocity for each, so let's go ahead and set the first one up. In trial 1, object A has a velocity of 5 centimeters per second to the right, and object B is stationary. I'm going to go ahead and hit play, and let's watch what happens. I'm going to go to Analyze, and what I can do, if I scroll back a little bit, is it will tell me how much force is applied to each object. So the effect and the force strength for object A, if I go back, was 100 newtons to the left, and object B was 100 newtons to the right. Now, what is the effect on each ball? What I want to put in here is the direction each object moves. So let's go ahead and watch again. Object A comes to a complete stop, and object B moves to the right. I'm going to record that here. Object A stops, and object B moves to the right. That's done. Cool. I'm going to complete this table. Trial 2, the initial velocity of the second object, object B, is moving to the left. So make sure that when I set up this, I can change the initial velocities by clicking on them. I want to make sure that the arrows are going to the left at 2 centimeters per second. I'll let you analyze the data and make your own conclusions. There's one last table, and these are different mass collisions. So I'm going to go back to force and motion, and I want to hit the top left menu bar and go to different mass collisions. I can see that these are different colors. That indicates that they're different masses. I'm going to do the same exact thing. So I'm going to record the initial velocity of each object. They looked like they were right the first time. And I'm going to record the effect of each object and the strength of each force. So let's go ahead and run. It looks like both objects continue to move to the right. So I'm going to go ahead and write that down. Moves to the right, and it was a little slower. So slowly moves right, and object B, it was at a stop, so it sped up to the right. Now the force strength. Again, if I go back a little bit to the actual collision, I can record and see that each object experiences 80 newtons of force. Now, I might see a trend. Why are these the same? Well, in any collision, an object is going to experience the same force on each object in different directions, and the effect might be different depending on the mass of the object, but the force in a collision is always the same. Go ahead and analyze, and what I just said was going to directly refer to question number 6. Forces are always the same in a collision. If you have any questions, please don't hesitate to reach out. You have my phone number at the top of this page. It's also in Google Classroom. Any way, email, call, or text, I'll be available to help you out the best I can. Hope you all are doing well. one more lesson, then the weekend, and I'll talk to you all soon. Bye.